The voltage at point A is 5 volts, and the voltage at point B is 0. If we connect these 2 points with a copper wire, which is commonly known as a short circuit, then the voltage at point A will be pulled down to 0 volts. And when we connect a 1000 ohm resistor and a 1000 ohm resistor, the voltage at point A will return to 5 volts. Why does connecting 5 volts with copper wire? Why the voltage is pulled down to 0 volts? For this question, many people are full of doubts. This is mainly because the internal resistance of the power supply. Every power supply has an internal resistance. The internal resistance of power supply is very small, usually not exceeding 100 milliohms. If we calculate with an internal resistance of 100 milliohms, for easier understanding, let's temporarily ignore the subsequent circuit. If it is connected to a resistor of 1000 ohms, according to the series voltage division, the voltage on the internal resistance is 0.0005 volts. The voltage on the resistor is 4.9995 volts. Voltage at point A is close to 5 volts, so it will not be pulled down. If it is copper wire, the resistivity of red copper is 0.018 ohms. If the length of this copper wire is 5 centimeters, the resistance of this copper wire is 1 milliohm. Now let's look at it again. The voltage on the power supply's internal resistance is 4.95 volts, while the voltage on the copper wire is 0.05 volts, approaching 0 volts. This is why after using copper wire to short circuit, the 5-volt voltage will be pulled down to 0 volts if the internal resistance of the power supply can also be 1 milliohm. The voltage of 5 volts will be pulled down to 2.5 volts. Only when the internal resistance of the power supply approaches 0. The voltage will not be pulled down, because the 5-volt voltage will be applied to the copper wire. But this situation obviously does not exist, because the total resistance is only 1 milliohm. According to Ohm's law, the current will reach 5000 amps. Such a high current is enough to destroy any electrical appliance in our home and in our daily electricity use. Even the most powerful air conditioner in our home, its maximum protection current is generally only 40 amps. That is, if the current exceeds this value, it will be cut off. Finally, let's talk about whether there will be a 0-volt voltage be raised by 5 volts. This situation also exists. For example, the resistance between point B and the negative pole to 10 ohms. If we short circuit points A and B with copper wire, according to the voltage division principle, the 0-volt voltage at point B will be pulled up to 4.95 volts. But this situation is extremely rare. Okay, this is my understanding of why high level is pulled down. Some simple understanding. I hope it helps you understand.